An estimated 2 billion people worldwide live in areas that lack proper solid waste management systems. Inadequate waste systems present serious risks to human health and the environment. The U.S. Environmental Protection Agency's Best Practices Guide for Solid Waste Management and accompanying learning modules present best practices for solid waste management in developing countries. This video builds on the energy recovery section of the Best Practices Guide to show the various opportunities and challenges of generating energy from waste. While the guide highlights multiple energy recovery processes, this video focuses on combustion, also known as incineration, including how waste is combusted, important environmental considerations, and an example of a waste combustion facility in Ethiopia. Globally, around 15% of all treated waste is incinerated with energy recovery. While the majority of energy recovery facilities are located in developed countries, the benefits of energy recovery can help all cities around the world meet their energy needs. Despite these benefits, cities should consider other forms of waste management and reduction first. According to EPA's waste management hierarchy, energy recovery is less preferable to source reduction and reuse, as well as recycling and composting due to potential environmental risks. Energy recovery may be more successful in cities that have established solid waste systems in place, have completed an effort to understand their waste stream, and have the technical and financial resources to ensure strict environmental protocols are in place at an energy recovery facility. Not all waste can or should be used to create energy, so it's important that decision makers have a complete understanding of their waste system before pursuing energy recovery. For more details on understanding different types of waste, visit Section 7 of EPA's Best Practices Guide, Waste Characterization. In general, paper, cardboard, plastics, bulky waste, and some hazardous wastes work best for energy recovery. Since metal cannot be burned, it is not usable for energy recovery and should be recycled whenever possible. Now, let's talk specifics. Combustion is a common form of energy recovery from waste. This process involves the burning of solid waste to create heat, steam, or electricity. It's important to note that waste combustion and waste burning are very different. While waste burning is typically done to increase space at landfills and releases harmful air pollutants, waste combustion is performed at specialized facilities with pollution control measures to reduce impacts on public health and the environment. And during incineration, the combustible waste materials burn when they reach a temperature between 850 and 1450 degrees Celsius and interact with oxygen. This process is called an oxidation reaction. Waste combustion for energy does not require additional fuels. The heat generated from burning waste can be used as a fuel energy for heat or can create steam for electricity generation. While the heat generated is a benefit of waste combustion, there are other outputs that can have environmental and public health impacts if not handled properly. The first is ash residue. Because incineration does not completely destroy solid waste, the process leaves behind two types of ash, bottom ash and fly ash. Bottom ash refers to ash made up of fine particulates that gather at the bottom of the incinerator during combustion. Bottom ash is typically put into landfills, but can be used more creatively as well. For example, in Bermuda, bottom ash was used to create ash concrete blocks, which were then placed offshore. Animals such as sponges and coral colonize the ash blocks to replace destroyed reefs. Fly ash is ash that enters the exhaust gas, another product of combustion. To prevent local air pollution, fly ash should be removed from the exhaust gas through a purification process. The remaining exhaust is then released into the atmosphere while the ash is taken to a landfill. Facilities should also consider how to reduce smells, noise, and vibration from the facility, and emissions or leakage from waste being stored for future incineration. These improvements ensure that the presence of the facility does not negatively impact nearby citizens. Let's jump to an energy recovery facility in action. Addis Ababa, Ethiopia, recently operationalized their first waste-to-energy plant. After many years setting up partnerships and funding sources, the REPI facility was opened in 2018. The facility, which was built on the site of an old landfill, has the ability to incinerate 1,400 tons of solid waste per day and generate 20 megawatts of power to the grid at the same time, which will be used to provide affordable energy to Addis Ababa residents. The city also sorts metals to be recycled ahead of the incineration process. Unfortunately, the cost of the facility and the lengthy planning process illustrate why energy recovery is often challenging to implement in developing countries. In total, the facility design and construction cost over $95 million and took 5 years to complete. There are systems in place that cities can use to generate income for energy recovery. These include direct waste fees from citizens, income from other fees or taxes, gate fees that are collected when waste is delivered at the combustion plant, revenues from the sale of recycled materials or recovered energy, local or national subsidies, or funds from other national or international organizations like the World Bank. Despite challenges, energy from waste can be a valuable tool to manage materials that are otherwise not recyclable while generating energy. Waste-to-energy projects are best suited to cities with functioning solid waste management systems and environment management protocols in place. Visit Section 14 of EPA's Best Practices Guide for more information on energy recovery. The guide is part of EPA's Solid Waste Management Toolkit. Scan this QR code for more information. Thanks for watching.